Hey, everyone.
Welcome to the Time CNC Podcast, your go-to show for precision, efficiency, and innovation in CNC manufacturing. We're here to help you cut time in all of your CNC endeavors. Whether you're a CNC enthusiast, CAD/CAM aficionado, or into robotics, this podcast is for you. Join us as we explore cutting-edge perspectives on machining metal parts. Discover the perfect tools and streamline your production processes. Precision meets progress on the Cutting Time CNC Industry Podcast. And now, here's your hosts, Al Martins and Stephanie Bate.
Always loved that intro. Almost went live without it. Steffi, come on for a minute and say hi to the gang. Always good to have my co-host actually appear. Hello, co-host. What a start today. I said I'm sweating.
Having some technical difficulties, but
wow. Talk about coming in the clutch. That was awesome. So we have a great guest today. We're excited to have him. I've known Kevin for years in many ways. Kevin Hesch, have I got that right, Steffi?
Yes.
Wonderful. Well, we know you're in the background answering questions. We're live. Where are we live?
Everywhere. LinkedIn, YouTube, Facebook, Twitter. And then we'll be on the audio platforms a little bit later.
Brilliant. All right, Steph, let's bring on Kevin. Thank you.
Bye.
Hey, Kevin, welcome aboard.
How are you doing, Al? Good to see you.
And you. Woo, that was cutting it close.
we were cutting it close. For the audience, I apologize. We had planned to do this on my computer. Unfortunately, I had some issues, so we are on phone, which we got on, what was it, about 5 seconds before this started, I think, Al?
Talk about coming through in the clutch, as they say. Woo! Well,
oh, yeah. Gotta love it.
We got to, that also speaks to redundancy. Glad you had a nice Samsung phone. You're coming in clear and you're 5x5, so it looks great.
Perfect.
Yeah. So, Kevin, we've known each other for a little bit of time, but there's a lot of our audience who don't know who you are. Could you give us a little rundown on who and what and why?
Definitely. Yeah, we've known each other for a few years. I had a little bit more hair and not quite as much gray in the beard and stuff like that when we first met. But I come from a background in the software industry, so programming of CNC equipment, programming of robots using offline software programming. And I made a switch then to selling automated systems with a company called ICubed, Industry Innovators, Inc. in Stony Creek, Ontario. And what we focus on is custom machine and robotic integration. And we are a non-brand specific, non-process specific integrator, meaning we don't care what brand of robot it is that you want to use, and we don't care what the process is. We have a team of specialists that have been in this automation field for quite a long time, and we have expertise across a wide variety of various different processes. So yes, it's been a while. It's been I don't know, I guess it's been almost 30 years that I've been in the manufacturing industry and loving every day of it.
Well, that's great, Kevin. I know you came from a long heritage of CAD/CAM experience, and that's always a good thing, because when you get into integration, it really helps to have the background or heritage that you've had. It certainly, you spent a lot of years at Mastercam, right?
Yes, that's correct.
So that I think sets you up well with understanding. And there was a time that Mastercam had Octopus, though, was it? Did I get that right? They had a robot system? Software?
Yeah. So it was two products, actually. So when I was with them, we launched a product called Robot Master for offline programming of robots. So it is a platform that works across whatever the programming software may be. I can import NC code from a CAM system and then spit that NC code into 6-axis, 7-axis robot code, 8, depending on how many external axes you have.
Right.
And after Robot Master, it was then Octopus that we developed and sold as a software. So that's built on a visual components platform as a solver, and then they built their own custom interface and custom processors since then. So I've actually launched 2 different software products into the world, we'll say.
Yeah, no, that you can't forget that name. All I think about is the movie Octopussy. It was a great James Bond movie, and it was a great name for the product because it just made a lot of sense with the 8 arms, as it were. And robots are becoming an everyday thing. In fact, I am a little off topic, but there's a show on Netflix called Better Than Us. I don't know if anybody's ever seen it, but it's actually a Russian. I think it's a 2-season thing, but it really focuses on robots and robotics in the let's say future, and it's well done. So Better Than Us, if you're looking for a little show on Netflix about robots and what the future might look like, it's well done.
I'll have to check it out. I can't say that I've heard of it. So
yeah, it is a little out there, but you know what? When you see it, you're going to say, "Wow, we're not far away from this." With the AI stuff and the rest of it coming, we're really not far away from a world of every home. In fact, some homes own robots today with vacuum cleaners, but every home having a Jetsons-like experience.
There's very much a lot of home automation out there right now. There's companies that focus specifically on home automation now as well. So it's entering into our everyday life. And I think because it's coming into the home so much now, you're finding that people in industry are just adapting it a little bit more readily now too. There was always this fear. There was always this, is it going to take my job? Is it going to replace me? And, that's not the case. People have been afraid for a long time, but I think that we're, at that cusp where people are understanding that this can create work. This can create better jobs for people. So they're not having to perform dangerous tasks. They're not having to perform repetitive tasks. And it maybe puts them into an office if they want to program these robots and gets them off the floor if they're looking for an office job. So I think that the home automation has just helped to open people's eyes as to what automation is, what it can be, and how it can make our lives better.
Well, that's fantastic. And as people bring in questions too, we'll look at those on the chat there, Kevin. You'll see them occasionally. But I think we usually start out with 10 questions. We'll try to get through them. I got some ideas, and certainly the integration. The question 1, I don't know, Steph, you usually bring them up. What are the key benefits of integrating robotics into CNC? Let me let you run with that a little bit.
Yeah. We'll start down a path, I guess, first on what it represents to the workforce. What it represents to the workforce, I touched on a little bit, is it takes that repetitive task away from an operator so that they can focus on other tasks. So if you can have a robot that is performing the job of, let's say, just loading and unloading a CNC from a fixture of parts or a nest of parts, that operator doesn't need to spend that time. That operator can now be repurposed, and he can service a number of different machines if a robot is doing that work. So I think that it just gives time back to the personnel that are working in shops by using a robot to perform those repetitive tasks. And the next thing it does is it allows, again, more of a bit of a lights out kind of, is the term lights out, because you don't have to monitor that system as frequently as you normally would. If you had to be loading parts, if you had to be checking tools, if you had to be sitting there deburring parts, the robot can perform all of those tasks for you. So it lets you walk away from the equipment to perform other more important tasks than those standard everyday remedial tasks that maybe get boring after a while. So I think that it's a very good way to create time for people. And right now, in a workforce that is hard to come by, and maybe people would say a depleted workforce in skilled trades, as much time as you can create for yourself is a key benefit out there to why you would implement robotics, is to give yourself that time to reutilize your workforce better so that they can focus on tasks that that a robot can be performing for them.
Well, let me ask you this, Kevin. We're talking about CNC, and generally, I mean, our whole podcast is Cutting Time CNC Industry Podcast.
Yep.
Now, robots have come a long way, from just pick and place.
Yes.
But in your world, because you're kind of agnostic, you don't just focus on one kind of robot. You focus on solutions for customers, which is really ideal, and certainly that it always attracted me to your company. Let's say you have a legacy machine, and when I say legacy, not a current FANUC control. Maybe you got an old 5 series control.
Yep.
Can robots be used in that world?
Yes, as long as you have an interface to the machine from the robot. So the robot is either going to be speaking directly. Robots will come in some cases with we'll just call it a mini form of PLC so that they can communicate, or you can have an external PLC that's controlling your system in larger cells. So as long as I have access to some digital I/O of some point, if I have some Ethernet communications, that's better. But again, the older machines, digital I/O is something that you typically would have, or it's a card that you can typically still add. They're harder to come by for older machines now.
Right.
But as long as I've got an input and an output to control various different things in my automation cell, that's really all that's required. And then from there, we can do things external to the machine if options aren't there in a machine. And by that, I mean, people have had robots open a door if you don't have an auto door on a machine. Right. Or an auto door could be installed external to the CNC if it's not there. People have had robots doing blow off in some cases because their blow off nozzles can't reach a certain area and they're not getting all the coolant off the part or something like that. So before they pick the part with the robot, they're using an air knife to blow off the part to make sure that it's dry. So old machine, new machine, it's just a communications protocol difference, but we've talked to all of them. We've talked to machines from the 80s, and we've talked to brand new machines in cells that we've created for people. So yes.
And I thought that was really important because I said CNC, but it could be NC, and it might even be something analog where you could have some type of a signal bus that speaks to a PLC and does certain things that it needs to do until the signal's turned off or something along that line.
Yeah, no, you're exactly right. It's all about communications and how to communicate. And the people in the CNC world are great to work with. They've been doing this for a long time with different external elements, we'll say, other than robots. So they're always a great help if you do have communications questions on older CNC equipment. And like I say, we've been through it ourselves, so we've got a good handle on what that needs to look like for communications protocols.
Nice. All right, so that brings us to number 2. How does robotic automation enhance productivity? You kind of touched on that a little bit. Maybe you've got a couple of extra points you'd like to touch on.
Yeah. If we talk about what it brings to the equation, that is typically an unknown if you're using a human operator, and that is the fact that from the time that you turn the robot on to the time that you turn the robot off at the end of your day, or if you don't turn it off, your cycle time remains consistent. There's nothing that's going to interfere with that unless you have a broken tool, unless you have a power outage, things like that. But the robot is programmed to perform a task at a speed, and that will not change as long as nothing interferes with that process. So you get that consistency. So when you're quoting out jobs and you're trying to figure out how many parts am I going to produce a day, it's never going to change because somebody was sick, because whatever, somebody didn't show up, somebody's newer, so their time to get parts onto the CNC is slower than somebody who's more experienced. The robot is going to perform the same task over and over again at the exact same speed and the exact same cycle time for you. So it makes quoting jobs that much more efficient because you know exactly what your throughput is going to be in the shop at that point in time.
Yeah, that of course makes complete sense. Like with everything else, as long as the power is on, we'll be okay.
Yeah.
And potentially the internet or the intranet, those are the only real things I think that would slow things down a little bit.
But the thing with all this too is it's not just a robot. It's the options that you have on the CNC machine and the integration with the PLC system. If you do have one of these external issues, those external issues can still be communicated to the system and communicated to an operator who is either in the building or remote. And that can simply be a light stack that informs them there's a broken tool. That could be a message that we sent out to an email address that informs them that you're out of coolant. I mean, there can be sensors put on anything on that CNC machine. And even if you do have one of those faults, you can quickly get an operator in there to fix those faults at that point in time as well.
Yeah, for sure. And guys, when you're on the chats, whether you're on LinkedIn or Facebook or Twitter or YouTube, you can type in your questions, and we've got Kevin here who lives and breathes this every day. So don't feel shy to drop in any questions you might have. So it kind of brings us into number 3. Since you've been working deeply with many companies, what kind of innovative applications have you seen with robots on the CNC?
Yeah, so every robot cell that we do is fairly unique. There's not really an off-the-shelf offering that ICubed does. What we do is we go out to customer sites, we visit with them, and we look at what the need is, and then we come up with a system to address the need. So our systems, they'll range with respect to levels of innovation and levels of cost associated with that innovation. So we've done everything from a robotic cell that has simply a fixture nest for circular parts and a robot picking and placing into a CNC 3-jaw chuck with a compliant tool to make sure that we push the part into the jaw to make sure that it is seated correctly and it doesn't just go to a location. We've done secondary operations with our automation cells as well. So the introduction of, again, a compliant deburring tool. So once the part is done on the CNC machine, the robot would pick it out of the CNC machine tool, and then it would perform a deburring operation. And it's doing that while the next part is being machined on the CNC. And then we're taking it to a part dip to wash it off after the fact. And then we're taking it to an air knife to dry it after that. And then we're placing it onto a CMM machine so that it can get inspected. And then it goes back onto its pallet location once it's done for an operator to perform what other tasks need to be performed on that part. So it's very, very unique to customers, but I'll say compliant external tools, secondary processes for deburring, secondary processes for laser engraving of parts after they're cut on a CNC machine. So we'll take it into a light box. The robot will hold it in the light box. We'll engrave a serial number on while it's there, protecting the operator from the laser. And then again, presenting it to an operator once it's done. So there's a ton of different processes that can be performed by the robot that, again, when you talk about innovative things that are going to help cycle times, when your CNC machine is in cycle, that robot is free to do whatever it can do while the machine is in cycle. So if you have a 2-minute cycle time and it takes 10 seconds to load that CNC machine, you've got 2 minutes for that robot to be doing a number of other things. And those can be inspection, those can be deburring, those can be prepping the next part. So again, it is very customer unique to a customer that we come up with these different solutions, but we've done a ton of different things to address a need. And typically what most customers will do is they will start with, okay, I want a machine tending robot, and it's simply picking and placing parts in and out of the CNC machine. And then because you have the versatility of a robot that is not an off-the-shelf standard offering, I can introduce something after the fact. So I can now introduce a vision system to do an inspection of the part a year after I've done my first implementation of a robot to do my machine tending. And then I might find, you know what, I don't want this robot for machine tending anymore. I would like this robot to go and weld this part over here. So I'm going to change my end of arm from a gripper to a welding torch and change my programming, change my cell setup a little bit. But that's just the versatility of robots, is people repurpose them all the time for different applications as well.
Yeah, no, that's a good point. You don't think about that. You think a robot's going to be using that same cell forever, but like a CNC machine, it can be reprogrammed for another part. So, you might have to move the robot, but that doesn't mean you can't use it in a different application. I like that.
Yeah.
I like that. Now, not off topic, but certainly I'm sure would also help. In the last show, we talked about a scenario where I was at a location where they were actually machining live munitions. Robots might be really handy for hazardous materials and things like that. Did you ever run into that kind of scenario?
Most definitely. I mean, and we've had people from nuclear plants approach us. I mean, those are typically very, very large applications. When you get into those, there's different safety standards and regulations that you need to follow in those applications. So I won't say that we've done a lot of them, but the handling of hazardous materials, robots have been doing for a very, very long time. Um, and even just handling of sharp parts, handling of heavy parts. You can buy massive CNC machines that are probably close to the size of my house nowadays, right?
Yeah.
And some of the parts that you're going to put into those CNC machines weigh a ton. And to go ahead and use a robot to place that part, I've been on site at the likes of like Motomen and seen a 900 kilogram payload robot in action.
Yeah.
The thing is huge.
Yeah.
And the robot can do that fairly quickly. Fanuc has a robot that they usually take to IMTS that picks up an entire Corvette body and swings it around, moves it all over the place. Kuka has a Titan robot that they have for heavy payload stuff. So again, if you look at a danger element, you look at a hazardous material element, that's what robots are made for. They can lift heavy things. They can be put in high heat applications with the right robot, being a foundry grade. And they can handle hazardous materials with the correct protection ratings. We've done explosion-proof robots for magnesium deburring and fettling of edges and grinding of edges before as well. So people aren't aware that you can buy, in some cases, an explosion-proof robot to protect yourself in those combustible type environments, right?
Absolutely. Yeah, we've run into that before. All right, so that comes into our next question then. So what challenges might arise? And we're kind of touching on that a little bit, but this is more about integrating into CNC in the workflows and how they can be addressed. Because you can certainly have more than one robot working on a particular application.
Well, most definitely. I mean, the challenges are cycle time typically for most customers. So when you get into a high production environments, having one robot perform all these tasks may not necessarily be enough to meet a cycle time requirement from the customer. So you start introducing 2 and 3 robots. And my plan was to show examples of this, and maybe I can supply you some pictures you can supply to people watching this. But we have multi-robot cells where one robot is performing an inspection to figure out the location of a vein running through the inside of a part. And then that robot places it in a ready block for another robot to pick up and put into a robo drill for a machining application. And the robot itself actually becomes the fixture. The customer didn't want to pay a lot of money for a number of fixtures for a number of different diameter parts that they were machining. So the robot actually holds the part while the part is being machined.
Nice.
And the robot is acting as the rotary axis, so they didn't have to purchase the rotary axis on the machine. And then the machine is performing 3-axis milling on various different faces on that part as it indexes using the robot's 6-axis. So it all comes down to, again, the challenges are unique to customers, but I would say cycle time is typically the largest challenge. Second to that is costs. These things do cost money, and you typically have to find a robot supplier, and you have to find a network of people to supply tools that you require that meet a budget. And there are robots that are very expensive, and they are so because they have a number of different options available that maybe make things easier or help you out for a specific process. And there are much cheaper robots that are, not as feature rich on their controller, but they can perform simple tasks very, very well. So we can address the cost based on the partners that we utilize for various different accounts. And then other things come down to accuracies and repeatability. And some people think those are the same thing, but robots have a first path accuracy. So the first time they go to a point, they can achieve it to within a certain tolerance. But then the second time, the third time, the fourth time they go to that same point, that's the repeatability of the robot. So customers will have a specific accuracy. So when I'm placing a part into a CNC machine, I need to either place it very, very close to whatever accuracy they're trying to achieve, if I can with the robot, or I have to have fixturing in my CNC, which can accommodate for the inaccuracies of the robot.
Right.
So if my robot has a 4 thou tolerance in its repeatability,
Right.
but my parts need a 0.5 thou tolerance because I'm cutting whatever, aerospace parts, something else,
Sure.
then I have to make up for that in some cases with the tooling. And sometimes it's as easy as a centering vise so that it will actually center around part, but it's not always that easy if you're trying to turn a part that isn't necessarily cylindrical in the gripper. So you get creative with compliance devices in your fixturing so the robot can push against different locates in order to locate the part accurately.
No, that makes sense. And we're seeing all kinds of different machines, a bunch of Nakamuras and Mazaks come with their own robotic load unload systems that they're really fast.
Yeah.
And certainly they can communicate with robots on the external side of things, but a lot of times, I'm going to say years ago already, we've seen robots in the use in transfer machines.
Yes.
With optical systems, and things would come off the transfer machine and they would be oriented correctly to go into another transfer machine, just exactly the way it's supposed to be. And I think that's what you're talking about.
Yeah, exactly. And the other thing is we're talking about robots a lot, but automation doesn't necessarily always have to be robots. You mentioned a bunch of these machines, right? Machinos and different higher end machine models. They will have robot load, but it's not what we're thinking of as a traditional 6-axis robot all the time.
It's not
It
that.
might just be it might just be a 2-axis positioning arm that's getting things, right?
Yeah.
And you can get maybe more accuracy than you can out of a 6-axis robot that's using all rotary motion to place that part in some cases. So we've again worked on different applications where maybe the accuracies of the robot aren't enough, so we have to go to some linear actuation to create a arm to place parts versus a 6-axis industrial robot to place parts. So again, it's unique to each application, and you just build a system to suit the application.
Yeah, which is what you do. So that brings us to number 5, and it kind of leads right into what we're talking about. How do collaborative robots contribute to safety and the feasibility of in these machining environments, CNC machining environments?
Yeah, so we've gotten into a couple collaborative installations. We don't do a lot of them, typically because a lot of the cells that we're doing, production is necessary. So we want to be running the robot as fast as we possibly can. But collaborative robots definitely play an important role in tight spaces where maybe you don't want a huge amount of guarding around the robot. The thing that people have to remember with collaborative robots is the robot can be collaborative, but the tool or the process may not be collaborative. So when you have your pre-start review of that cell done, your process may not be collaborative in nature, because if you're cutting knives and the robot's taking the knives out of the CNC machine and swinging them around in space, yes, the robot will move slower. Yes, when the robot encounters force, it will trip out, but you're still swinging a knife around, right? So, so people have to keep that in mind with these collaborative robots. So what I will say about collaborative robots, we've used collaborative robots in non-collaborative modes because the programming interface for collaborative robots is often much, much easier than your standard programming interface for an industrial robot. The industrial side of robotics, they're starting to take notes from the collaborative side of the robots, and you're starting to see easier programming interfaces on some of the newer controllers. But the collaborative robots take me back to, like, I know it's a long time, but take me back to my high school days where it's simple ladder logic and stuff like that, and dragging and dropping things below other things to change a sequence of events. And it's pretty slick, and it doesn't take a lot of training to get somebody up to speed on how to program a collaborative robot. So I would say that is my favorite feature about collaborative robots, is just the ease of programming of the collaborative robots.
Yeah, I mean, some of them, of course, years ago we used to call them teach systems, FANUC teach controls, where in fact you would teach it how to, effectively airbrush a car, or it would follow your motion and it would learn that way. Not
Yeah,
necessarily collaborative, but certainly collaborative in the sense that it was human robot interaction and it learned from you to become useful.
yeah.
You know,
I
it's kind of,
remember old tracer mills back in the day, right? You call those the first collaborative machines, right? Where you
that's
just
true.
have a tracer head that you're dragging all over a part, and there was a follower head on the other side cutting the part for you, right? So
Absolutely, like those old purposes, you're moving a monstrosity machine, and wow,
yeah,
they were pretty incredible, weren't they?
oh yeah,
Um,
yeah,
but safety is one of the key points, and I know there's several companies. I think there's a fairly significant German robotics company that does all kinds of safety training and so forth in Europe and Canada. Um, but as robots start to become mobile, that creates another level of, we'll say, production efficiencies, but also some concerns. And it was interesting. You're talking about swinging knives, and I'm going to go back to that Netflix Better Than Us. The primary, it kind of leads into our next question about AI, directive of these robots that they would never harm a human. So, and we might as well just go right into the AI. What does artificial intelligence mean in the world of robotics today? Because they're all kind of aligned into this summary of safety as well.
yeah. It's a very large topic, and AI can include a number of different things. So I think AI plays a very important role for complex applications, and some of those complex applications might be, let's say you didn't have a neat little array of parts that you're loading into your CNC machine. Let's say you have a mess of a cage of parts in a
Right.
random array that is sitting in front of the CNC machine that you now need to teach to pick up a part and put it into the CNC machine. This is where your AI and your learning kind of comes into play. There's a lot of different companies out there doing exactly that, things like 3D bin picking and using AI to have the system learn how to pick up those parts, how to recognize the parts, um, how to prioritize the parts in those bins. So typically they have a bunch of cameras overhead and they are figuring out a match percentage to an ideal part. So if
Right.
I match to within 85%, but then a part in the left corner matches to within 92%, we'll pick that part in the left corner first and then pick the other part after that. So it definitely plays an important role. I am by no means, the key person to talk to on AI. We've barely skimmed the surface of what AI is capable of doing. But I think that AI also has a deep learning when it comes into exactly what you just talked about, Al. And you talk about the mobility of robots and robots now moving around plants and moving around factories. Your AI plays a huge role in how that AGV, right, that automated guided vehicle,
Yep.
is transitioning through a production environment. And when it encounters something that it doesn't recognize or hasn't been trained how to recognize, what set of rules dictates what that AGV is doing? Does it stop and just shut down and wait for an operator? Does it try to find a new path if there's an open path somewhere else? If it can deviate slightly from whatever path it was following, these are the applications where you're going to see artificial intelligence used all the time. And yeah, bin
Yeah.
picking, AGVs, these are kind of applications that we've looked at using artificial intelligence. And then again, vision and various different vision systems are now incorporating AI to help teach in different part variants. So if you are a shop that programs 5,000 different parts that are maybe somewhat similar in nature but not the same, people are using AI and vision systems to try to detect key features and feed information to the CNC machine about how to machine a part, how to deal with maybe wear on a tool, how to do a lot of different tasks.
No, exactly. And this, as you say, it's a huge topic. We could be hours on this, to be honest. But simply we look at things way back when we were kids. Remember Sesame Street? One of these things doesn't belong here. Which is it? And we've seen on YouTube the example of the Tesla robot looking at using AI, and it was the example of the human talking to the robot effectively through AI and said, "What do you have on the table that you can offer me to eat?" Did you remember seeing that?
And I've heard of this. I haven't watched that video, but yeah, I can talk on this a bit too in a bit. But go ahead.
Yeah, but effectively the robot analyzes the table, whether that in this particular case he saw an apple, and that's the only edible thing that he recognized, and he picked up the apple and gave it to the human who was requesting it. So that's AI really working at a significant level. And when we look at that in the manufacturing world, we have, I'm going to call it analog, although it's not analog, but vision systems and all the rest of these systems are pretty much, 0 and 1. Is it good or is it bad? We can get really relational with that once we get AI involved.
Well, you can live in a gray area. Like AI needs what's the word I'm looking for? You need to have a good way to teach AI what an outcome is, because again, if you bring up past examples, there were AI chatbots once upon a time, and they were trolling the internet to have conversation, and then it just divulged into just berating people with insults and stuff like that because they were trolling too deep into the internet, and it just got messy, right? So to train AI what to do and to set up these rules for it to follow and what to do and lead it down different paths becomes a very important part of what the outcome of AI is going to provide an end user. So you have to be very careful when setting these things up, I think.
Yeah, of course. And those days are coming, and they're coming fast. And that's why I dwell on it a little bit, because we think of robots as basically pick and place, do this or do that. But robots are collaborating. Robots are doing things together. And AI is really down the road. And it kind of leads us into our next question here. And, do you have some examples of where, the robotic integration has transformed the specific industries, for instance?
Yeah, and really, it's so I'll talk about specific applications and how it's helped out in those applications, and a lot of this relates to preventing injuries in industries where you have a lot of hazardous materials. It speaks to a reduction in people being able to find skilled labor, so they're introducing robots in order to help with a shortage of labor that they might have. But if I give a couple examples, let's talk about the foundry industry and pouring of molds and stuff like that and casting. So
Yeah.
that's an industry that now you used to see people reach into these molten pits with a ladle, or they're operating a crane with a ladle to pour a mold that's overhead, and it's just hot material being spewed and splashing kind of everywhere. And that's an industry where you will see typically nothing but robots at this point in time doing a lot of those applications, where your robot is dipping into the molten material to pull up a certain amount of material. It is what is pouring the mold and keeping the operator out of that hot environment. And then the operator doesn't have to get involved until after things become much, much more safe than dealing with that type of material. So again, when dealing with hazardous materials, that's where automation plays a key role in reducing the risk for people and getting rid of a lot of workplace injuries that might occur in those types of environments. Other environments that it's kind of transformed is, maybe it's not necessarily a specific field, but it gives people more operating time without necessarily having people there. So if we go back to a simple CNC machine loading application, if I can populate a fixture with 40 parts and I have enough tools in my tools, maybe I've got some redundant tools in case I witness a tool breakage. At the end of my day, if I'm an operator, at the end of my day and I'm walking out the door, if I have those parts populated in that fixture, that thing can run for as long as it takes to run those 40 parts, those 200 parts, whatever you can put in process. So it gives people the option to work longer hours without necessarily working longer hours in some cases. And that helps to drive costs down. I mean, we're living in a world where costs are just going up and up and up and up and up and up. So if we can find a way to squeeze some extra hours without throwing a whole bunch of bodies at a problem, or without needing to spend a lot of cash in expensive equipment, a robot is a fairly inexpensive option to give you more hours on that machine to produce more parts at a reduced cost then as well. So it's something that can save people quite a bit of money.
And that kind of really leads into the next question about a lights out environment. When we're looking at lights out, there are costs, there are hidden costs. I want to say hidden, but certainly there's obviously implications to scaling, what it would cost, what the power costs. When we're trying to reshore work, it is all of these, there's a ratio to the cost of a robot, the cost of the power to keep it alive, programming it and the rest of it. Where is that leveling out? Where do you see that? Is that becoming easier to get to?
I think that it is, because the tools are becoming easier to support what you see in most shops. So few and far between are the shops that cut one part all year round and that's it, right? Yep. It's very easy to create an automation cell for one part being cut all year round in a machine. And that's something that pays for itself in a fraction of the time.
Yep.
What's difficult is that most of the shops out there are guys that are having to hustle to work, and they're pulling in different jobs and new jobs every day. And how do you automate something that has a low batch run but a high mix in product? And the tools are available now to assist with that, using things like vision systems. So recognizing the shape on the parts, the robot can grip in a different fashion if it's a different part that's put into process. Having adaptable fixturing so that the fixture can hold multiple parts, and using the engineering skills to create those types of fixtures for parts. So I'll say automation is becoming something that can be used more for a high mix, low volume environment. And the lights outside of it just means that now you can load 10 different parts into your automation cell. The vision is recognizing which parts when it looks at the part, and it's calling the appropriate program on the CNC machine tool based on the part that it's recognized. It's placing the part in the correct orientation because it's recognized what part it is. So that's really been kind of transformative in respect to lights out manufacturing. Now, the other thing, you can run lights out manufacturing for as long as you can populate parts in front of a robot. So people have gotten smarter about, maybe I put those parts on a moving conveyor, because now I can fill an entire conveyor full of parts, and I can use a vision system to find the part on the conveyor. So I don't have to have them in this neat stack. People are implementing drawer systems you see all the time, because now you can utilize the vertical space that a robot can reach to instead of just a horizontal reach and putting multiple fixtures around it. Now you can stack drawers up on top of each other, and the robot can pull a drawer open when it's in process on that drawer, and then close the drawer when it's done processing that and open the drawer below it. So you can run lights out for as many parts as you can fit around a robot. And if you think of the work zone of a robot, it looks like a very thick donut. It's a revolved surface, but the robot has a lot of vertical reach in that revolved surface too. So you can be stacking parts on top of each other. So when people are thinking about lights out, they should also be thinking about going up with their cells, not just out and around with their cells.
That's a good analogy. I like that. Now, we have bar feeders. We have, they can be stacked. Can a robot reload those stacks?
If it can reach it, it can reload it for sure.
Okay.
Yeah, right. It all comes down to what are you doing? What are you reloading that stack? We'll have magazines of parts. If you think of like a coin exchanger where you have stacked parts on top of each other, and then we
Right.
push a part out at the bottom, they fall, push a part out. That's if you can have parts that can scrape along each other for a purpose of what your surface finish needs to look like. But what that does is it creates one pick spot for the robot. So your robot programming is very, very simple because it doesn't have to go to 10 pick locations. If you have 10 parts in that magazine, the robot's going to one pick location every time. And you're not having to pick from the top and then constantly move down, pick lower, 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 because it's always coming out in the same spot. So yes, it can reload a magazine if it can reach the part and if it can put the part into the magazine. So it all just comes down to how you've designed the system and then how are your loose parts getting to the robot so that it can potentially reload that magazine.
Now, how about just again brainstorming with you on this because it's really exciting. I'm happy to talk to you about this topic. If we had a magazine situation and we have tool life management,
Yeah.
can we have robots reloading magazine positions? Let's say on a horizontal or whatever kind of mill it might be, or even a mill turn center that would recognize, hey, these tools need to be remagazined.
Absolutely. Absolutely. Because all you would have to do is have a station with your redundant tooling in. So let's say your CNC machine A maybe doesn't have a tool change station. I don't know. Or B doesn't have enough tools because you use 20 tools, but you only have 20 tools on your CNC machine. So now you want some redundancy in case you run into some wear issues, in case you run into some tool breakage. You can have a station outside of your CNC machine with simply the tool holder, the tool in it, and the robot can pick up on the tool holder. And just like you would have on your CNC machine, it'd have a two-sided tool where it would go in and it would take one tool out of the spindle of the machine, and then it would place another tool into the spindle of the machine. Now, you would probably want to do a couple things. You might want to have a Renishaw system for setting the height and setting the diameter offset of that tool just to check it, or you preset it and you know exactly what it is before it goes into the robot cell. And the robot, when it performs the tool change, can speak to the CNC machine and populate your tool height offsets for you and populate your diameter offsets for you if that is information that you've already provided the system through maybe an HMI system of some sort.
So, it kind of branches off from there. So now we've got, let's say, tool life management working with the robot.
Yep.
And we've got that, Renishaw, Bloom, whatever the system is that they have in place,
Yep.
Calibrating those tools. Let's say the part comes off. So now we have the robot, it takes the part off and inspection.
Yep.
There's robots that deal with inspection. So let's say it was a 10th drill and it broke.
Yep.
And in fact, the part is non-conformant. All it really has to do is go back in and be rerun again. Are there systems in place that will recognize that and say, hey, I'm going to put it back in so they can rerun that operation or that particular sequence?
Absolutely, and they range. You're talking about like vision systems. So the robot can take a part to a vision system, and a camera will then give feedback. And those cameras range in their complexity and what they can do. So you can have just a comparator camera that is basically taking an image of a part and comparing it against a master and saying, do I match or do I not match? And if I don't match, those comparator cameras might not have a lot to do with anything other than saying it didn't match and put it somewhere for an operator to deal with. And then you can get into vision systems that can actually take measurements. So now your vision system can go and you can say, okay, I'm going to present the part in this fashion. I need you to check this hole and tell me what the inner diameter is. Tell me what the outer diameter is. and based on that feedback, put it back in the machine, update some wear offset values in the machine, and rerun program XYZ, right? So you
It's
can get
nice.
into those systems, and those are still non-contact. If you need to get very, very accurate with measurement, you can introduce touch probe sensors as well, things like LVDT systems, which is a contact probe that'll give you a very accurate reading on a part. So the robot can hold the part, LVDT can engage on a surface, take a measurement, and give you, measurements that are closer to the hundredths of a thou instead of a couple thou, right?
Right, exactly.
So it really all depends on what you're trying to achieve. So can it be done? Yes. It's just a scalable solution depending on whether it's just a go, no go, or is it a what's the measurement, and then what are the tasks that I want to do once I figure out what that measurement is, and then some PLC programming to then interact with the CNC machine to perform some tasks based on the measurements that were taken.
Well, we could go down this road for a while.
Well, I can't keep up with the technology, right?
I know.
I know a little bit, right?
I love it. So we're on number 9 here. What are some of the considerations for selecting the right robotic system? And seeing as you're agnostic that way, tell us about that.
Yeah, really what we tend to do is we go to site and we do tours of facilities, and then we pick applications with customers, or they tell us what they're interested in. If I tell you what's best, is it's look for a repetitive process. And I'll talk about maybe different application now, other than CNC, but just to kind of lead people down a path. I visited a customer who wanted to build an entire panel. Okay, and that panel consisted of a number of different parts, and those parts were all different. And I told him to strip the process down. I said, don't worry about the panel. Let's not build the panel. Let's look at the task that is repetitive. And the task that was repetitive is they needed to screw, every piece was screwed together in some way, shape, or form.
Sure.
And then every piece needed a bead of silicone put around it in some way, shape, or form. So let's not build the entire panel and make $1 million system. Let's screw all of the X cross members to the Y cross members and put silicone around all of them, and then take it to the next stage, and an operator can perform the next task. And then once you're happy with that, then let's build the next stage. So I guess what I'm saying is when you're looking at an automation project, sometimes it's better not to look at maybe what you want the 5-year plan to be for that automation project, and focus on what you want the right now need to be, and just strip it down to a more basic level. Because everyone thinks of a robot and they're like, well, it can do anything. I can put 20 different tools on it and I can perform 20 different tasks. And you're right, but most people don't have the budget to perform 20 different tasks.
Right. And
they should probably focus on that one repetitive task, and then scale it, and then scale it, and then scale it.
Baby steps.
That's exactly it. Do it in iterations, right? So
baby steps. I think of baby steps, and I think the word Bob. I'm not sure why. I think he was the psychologist. Or what about Bob? Wasn't it something along that line? But absolutely. So brings us to our last question. So what do you foresee the future really in robotics and CNC? I know that's a really tough question to grapple with because it's changing exponentially, but what are your inside thoughts?
Yeah, it is a very tough question. What do I foresee happening? I think that you're just going to see that people have to get more engaged with automation if we anticipate that we want to be competitive with the likes of, Chinese prices, and with the likes of the labor costs in Mexico and stuff like that, right? We have to do something different. And if we look at the robotic integrations in Canada per capita when stacked up against other countries, we don't rank very high, right? So I think there's a lot of room for growth in Canada. I think that we're maybe more hesitant as Canadians to adopt new technology. We like to wait, and we like to see that it works elsewhere. And once we see that it works elsewhere, then maybe we're willing to adopt and look into it. But by that point, we're already behind. So where's robots going to take us? Where they can take us is they can make us more competitive. they can help to drive the cost per part down by integrating automation. And I think that we can get there for mom and pop shops just as well as we can get there for huge corporations by, again, keeping it simple and using the robot to start to do simple things and then grow it. And I know I'm a little bit repetitive with my answers. I apologize. Just trying to drive some
No,
points
not at
home.
all. Not at all. The point, I think, Kevin, too, is we look at, this podcast is international.
Yep.
And we think of certainly Canada or the US, and sometimes, they've been a little bit slower to adopt. In Europe and Asia, robots have been around possibly about just as long, but the adoption rate is higher.
Yes.
You think that's a psyche thing? What do you think? Why is North America a little slower to adopt?
Yeah, I've been to Japan, I've been to Germany, I've been to China, I've seen those plants.
Yeah.
Why are we slower to adopt? I don't know if it's just a psyche of who we are and how we operate, and everyone's thin on cash. But I can't say that people aren't thin on cash in China and thin on cash in Germany and everywhere else too. But you watch these. I think it was a LinkedIn post that showed the robots per capita per country, and Canada way back when was like top 5, and it was keeping pace in like the 80s and the 90s. Then it just slowly kind of tapered off and tapered off and tapered off. So we're still there, and I think that there's still lots of potential for it to happen. I don't know how to answer the why. I'm really not sure. The Germans love to integrate new technology, and they'll throw something cutting edge in, and they'll throw a ton of money at R&D, and maybe there's an influx of R&D funds in some of these countries where they can create cells, not necessarily on their dime, and receive funding from governments and various different companies to prove these tasks out before they implement them. So that could be something that's available. I know that people always talk about funding here in Canada and shred funds and stuff like that, but it's not what it used to be even 5 years ago. People's shred amounts have drastically dropped over the past 5 years. I know ours has as well, because we're typically doing new creations for people, and we used to have a certain amount that was shreddable, and we can't do that anymore. It's just not possible with what's available here. So
yeah, the complexity of world governments for sure, and what we're focused on in manufacturing is something that we're trying, as I say, to reshore in North America. We have to get smarter and better. Robotics definitely going to be a piece of that. We were at the Sandvik factory last year, and really it was amazing to see that the hallways were filled with robots moving up and down, picking up components and bringing things over to the stores. And it really is a reality. And when you go to automotive plants, you see a little bit of that as well. You're starting to see less forklifts beeping their horns around every corner. You're starting to see more robots flashing their lights. So we're getting there. But I think the point you brought up at the beginning is robots being used in applications where you're not making millions of parts, but you're able to use it in an array of components coming off a particular machine, no matter what the component is.
Yeah.
I think that's really thinking outside of the box, as it were. Yeah.
If I think about just, again, what's going to help this industry, it's just, again, making automation affordable for the small shops, right? Making automation affordable for the guys that have 10 employees. Not, it is already affordable for those huge companies, those Teslas of the world, those Magnas of the world and stuff like that, because they integrate thousands of robots, right? So it's just, let's strip it down. Let's make it affordable for everybody out there. And we do that by just simplifying what customers need, and maybe simplifying some of the hardware that's required in some of these cells too.
All right. Well, we're this, we've gone through our questions, but I'm just trying to, again, think outside of the box. If you're a company that has 2 or 3 CNC machines,
yes,
and you've been thinking about, what you can do with a robot,
yep.
What recommendations would you have for somebody like that? Should they be reticent, or can they jump in somehow and take a baby step that would help them leverage the equipment they have to the next level?
Yeah, so robots can easily be integrated into multiple CNC machines. Like a typical robot has a reach, well, they have various different reaches, but and again, I had pictures to show it. I apologize.
That's okay.
But you can get a very, very small robot. I had an example to show at a customer very close to our office that implemented a 700 millimeter reach robot that loaded 4 different styles of parts into a robo drill that put those parts onto a conveyor. That conveyor took those parts into his tumble deburr.
So that's like 2.5 feet or so?
Yeah, 700, about 2.5 feet for 700 millimeters. Yeah, exactly. So that was a very low cost. That cell, I can't recall the exact number, but it was a small robot. It was a single gripper that was multifaceted, but it did multiple things for the operator that took them away from the machine and got them engaged in engineering and designing new parts, because it was a small company, got them engaged in the marketing of their new materials. So it is quite easy to integrate a very small robot system into a CNC machine. And now if you upgrade that robot a little bit and you go to a 1.5 meter reach robot, you can put a single robot in between 2 CNC machines, and it can be loading and unloading both of those machines from one cell, right? You can actually probably do it in 3. And I would recommend you do it through the side door in the machine tool versus the front, because it leaves the front of the machine open in case the operator does want to operate that in manual mode at some point in time. But we've done multiple CNC machines with one robot, and then you just upgrade. And now when you buy your 5th and 6th and 7th CNC machine, and again, I had pictures, but you put that robot on a rail, and that robot now traverses down a rail, and it can service a number of different machines. And we did that for a customer that had a longer cycle time on his machines. So rather than his robot being put in front of one machine, he has one robot on a 15-meter rail that services 3 machines, puts it into a CMM, puts it into a part wash, and has 108 different pallet locations that they can pick from and put a different part in each pallet location. And now you've got a barcode reader that reads the pallet and knows what part is in the pallet, calls the CNC program on the CNC machine tool, and then executes the pass for that specific part. So again, start simple, put a robot in between 2 machines. As your company grows, you just grow that cell along with your company.
Well, that's brilliant. Thank you for that. I think that's exciting. And cutting time is the theme of our podcast. And I think eventually every home will have a robot if you don't have one already. Years ago, we didn't think we'd have 3D printers, but almost everyone has a 3D printer by now, or has played with one. And I think robots will find themselves into your homes. But certainly if you don't have one in your shop, you might consider some type of small automation. And certainly ICubed and Kevin, thank you for being with us tonight.
I appreciate you guys having me. Hopefully you guys enjoyed this, and here for any questions that come up after the fact too. Brilliant.
Well, Kevin, have a great evening, and thanks again for being with us. We'll look forward to seeing you again soon.
Thanks, Al. Appreciate it. Bye now.
Cheers. Bye-bye. And we'll get Stephanie back up here. Let's close off the show, Steffi. I think we lost your voice for some reason. There it is.
There it is. It's been a technical difficulty type day.
Brilliant. So, Steph, what have we got? It was really nice being with Kevin and going through this whole podcast. I think it was a great show. I learned a lot myself, I must say. Always learning. What do we have coming up next week?
Ta-da.
Yes. Yeah. I say next week. I'm sorry. In 2 weeks from now.
Yes, 2 weeks. We got the mastering machining tips for efficient metal part production.
I think that's Keith, isn't it?
It is, yes.
Yeah. Well, we look forward to talking to Keith Leonard next week and on that episode. So yeah, let's play our outro. Thank you, Steffi.
Thank you.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast.